Hope you are awake today, because we are about to go fast. We are going to do a speed lesson on how to calculate extrema, also known as the first derivative test. No memes or anything like that. Ready? I hope so. Extrema, plural form of extremum, is defined as the minimums or maximums of a function. Extrema fall into either two categories. The first is the absolute extrema, the lowest minimum, and slash or largest maximum of the entire function. The second group are relative, or local, extrema. These extrema are maxes and mins relative to a certain part of the graph. They may not be the largest maxes or lowest mins of the entire function but are in certain intervals. Mins and max, and in extension extrema, are determined by a sign change at a point, but we will learn that later on. Extrema are important, because extrema detail relationships of a function. The extrema in a velocity function, for example, shows a change in direction. Since we now know what extrema are, let's find how to calculate it from a function using derivatives. To find the extrema, first we need to derive the function, then find the x values of the zeros and does not exists of the function. These points will give the critical points of the original function. However, critical points are not the same as extrema. Extrema are minimums and maximums, but critical points are any point where f of x have a zero slope or does not exist. This point is not an extrema because the left and right of the point is decreasing. We need another step to differentiate between extrema and critical points. A nice and easy method is to use a sign chart. We will use this method for finding the extrema for the following equation. The first step is to derive it. Then find the x points where it equals 0 or it does not exist. That happens at x equals 0, x equals 1, and x equals 2. After we find the critical points, we use a chart like this one. We plot the critical points. As you can see, f prime of x at these points are 0 or does not exist. Then, we need to find a value between each point, to find whether f prime of x is positive or negative at these points. First, let's try -1. This will show whether the left side of x equals 0 of the original function is increasing or decreasing. Plugging -1 in f prime of x will yield 3/4, or a positive value. This means f of x is increasing on the left side of x equals 0. By doing this 3 more times to determine negative or positive slope between each critical point, we will able to determine the extrema. Extrema are critical points that have a sign change at that point. X equals 0 is an extrema, because there is a slope change occurring at that point. X equals 1 is not an extrema however because there is no sign change. F of x is decreasing on both the left and right side of that point. X equals 2, like x equals 0 is an extrema, having a sign change. This original graph of f of x has 3 critical points, but only 2 extrema, at x equals 0, and x equals 2, so that is how to find the extrema of a function. Easy, right? Finding what the absolute extrema requires plugging the extrema x values into the original function, but I'm sure you can do it. This took a long time, and I'm glad it's over. Bye peeps.